Good afternoon, and thank you for coming to this talk. I'm Asad Ali, and I work in the CTO office of Thales, based here in Austin. When I was looking for a title for this talk, or rather a topic for this talk, I remember this meme which I read many, many years ago, and then realized that what this meme talks about is still very relevant. We are still dealing with issues about identity and authentication and access management online. So those items are, and those topics are still very relevant and dear to our hearts. So what this meme is, so let's go through this meme and then we'll go through the details of what we talk about. So this thing was a cartoon by Peter Steiner that was published in the New Yorker back in the 1993. And what it is about is that there's a dog that is sitting at the console on the computer, and he's looking down at another dog that is looking up, quite surprised, and he says, "Don't worry, on the internet nobody knows you're a dog." And the New Yorker, this is one of the most publicized and published cartoons from the New Yorker, and the reason, of course, is because it's still relevant and people can still relate to that. So with that backdrop, let's look at what we will talk about. So I want to focus on identity, authentication, access management, single sign-on, all the things that you are very familiar with. So from that point of view, I mean, I'm in a way speaking to the choir because you guys are very well versed in this. I will not have any detailed protocol diagrams or protocols or details, technology flows, nor source code, God forbid. However, we will look at things that we know about, but we'll try to see them from a different perspective. And the goal is that by looking at it from a different perspective, we can see where the future is moving, especially with this backdrop of all the hoopla about artificial intelligence and machine learning. With this strong focus on that, we'll see where we are and why these things matter. So with that said, let's start with identity. And when you look at it, so I often show this picture and say, okay, well, what does identity have to do with this picture? So just for the sake of clarification, I mean, this is still taken from the movie Glory from 1998. Good film, Morgan Freeman and Denzel Washington. So if you've not seen it, I mean, this would be a good one to watch. But the way I see it, I mean, there are two things which are pertinent in this, how it relates to identity. There's one which is recognize and the other one which is relate. So recognize is so that others can recognize you, and relate is more for you. I mean, you want to relate to a particular cause. In this case, they're relating to the Union Army, and then of course there will be counterparts who would be relating to the Confederate Army. So in both the cases, I mean, there's this concept of relating to something and then being able to recognize. The same thing we see in the more contemporary era. So here we have the Patriots and the New York Giants. And for them, again, it's a concept of, okay, being able to recognize each other on the football field and also to relate to a particular cause, a particular franchise. Now, of course, some may say that, well, the players don't relate to the franchise as much as the fans do, which I guess is true to some extent. And for the Patriots fan in the room, I mean, if you are a Patriot fan, I mean, of course, you'll be very happy because 7-0 up in this season, so that's pretty nice. On the same front, I mean, I have another. Still, this one is from Valkyrie, and the difference of course over here is it's not a uniform; it's something that they're holding. So this is again a nice movie with Tom Cruise and Tom Wilkinson. Nice cast, and it's a nice fast-paced movie. So if you have not watched it, this would be another recommendation. And what you see over here is that they're holding up something which is serving as an identity card for them. And of course, I mean, I won't give away the plot, but essentially what you want to be seen as part of a circle. And this is the ID card that you have. So this is more like the bearer tokens that we know of in the authorization space. If you have a token, you get access. If you don't have a token, you don't. So there's little to do with identity at this point, other than the fact that you're part of a clan. Now, at the same time, I mean, we do have examples, and we have been living with them, those examples of how we actually get identification tied to a token. So this is an ID card long time ago when I had hair and black hair. And you can see that this is a paper card with laminate on it. Now, at the same time, a more recent version of that is much more sophisticated. So it's not a laminate. It has printing which is done directly on the card body itself. Then it has a hologram. It also has a mag stripe at the back, and it has a smart card chip, which has biometric information in it. It can do match on card. It can do all those things. So essentially, there's a sophistication of how we have evolved these permanent identifiers in the physical world. Now, these are permanent, and the way we use them, we have established protocols and norms on how adaptive authentication or adaptive verification of users would work. So you go to a bank teller, and if you're depositing a check, they will probably ask you for no identification at all, or maybe just one ID without any picture. That would suffice. If you are withdrawing money, now the authentication bar goes a little bit higher. I mean, you'll be asked to show 2 identifiers, and one of them has to be with a photo ID. The same thing happens when you're dealing with IDs which are not permanent, which are temporary. So here's an example for, let's say, if you go to South by Southwest and you're given this badge, and this badge doesn't have the same sophistication that I showed you in the ID card, but it does have probably an RFID. It has a QR code over here. So I mean, there are things that are used to identify you, and the way you use them is still adaptive, just like we saw in the example of the bank teller. So if you are going into the exhibition hall, probably they'll just look at the badge, say, okay, you have it. From a distance, you're fine to go. If you go to some sessions which are more protected and guarded for whatever reason, either because of security or because there are a lot of people who want to attend them and they want to control the access, they may actually scan the badge, in which case your identity actually is seen in a more prominent way. So with these identifiers, the question is that we have done that in the physical world. I mean, we have these models and we have these systems that make up. How do we handle them in the online world? And when we talk about the online world, you go back in history and say, okay, well, it really started in the 90s. And there are 2 players which I'll mention which are dominant in this, and just for the sake of mentioning. So the first one is Sun Microsystems, which no longer exists. I mean, it was acquired by Oracle some time back. And I remember that back in those days when I was visiting my brother, incidentally, he worked for Oracle at that time. Didn't realize that they would end up acquiring Sun. You would drive on Highway 101 and you would see these signs. And this sign was an advertisement by Sun, and they would say that we are the something in .com. And what they were saying, what it meant, we are the dot in .com. Because again, I mean, the high power servers that Sun was creating on the back end, I mean, that was driving the growth of the internet. So that was one play that was dominant. The second play that was dominant is Netscape. And when I say Netscape, I mean, sometimes I mispronounce it as Netscope, which is more dominant these days. But Netscape, essentially, their contribution is coming, of course, they created this browser, which was the access device that people used. But more importantly, they made that interaction secure. And they made it secure by this patent, which is on SSL. So this formed the basis of how the internet basically boomed in the 90s and then 2000s. And interestingly, I mean, so this was issued in 1997, and in fact, less than 2 years after it was filed. So on the patent world, in software patent world, I mean, this was a very fast track. I mean, they got it fairly quickly. Now, the reason that I mentioned that is because what the SSL protocol does is pertinent to how we define identity and how we authenticate users in the current space. So here's the SSL handshake protocol. So before they go into the actual data exchange in the application, SSL, the protocol itself, at the transport layer, they have to exchange information. So this is to essentially establish the session keys and all that. So the main points to remember over here, I mean, there's a lot of detail in terms of how the client hello starts from the client side, and then a lot of steps happen back and forth. And then the idea is to go from the pre-master secret to the master secret, and then that is used to create the session keys, which are used for each round trip. But if you look at number 3, that's the server certificate. So the server certificate is sent by the server to the client. Now, in the protocol, it's not mandatory for the client to send back the certificate. So essentially, it's not a mutually authenticated protocol at that level. The mandatory part is only on the server side. And the reason for that is when you look at how it was used. So essentially, I mean, you want to make sure that if you are connecting to a website, that website is who that website claims to be. As far as you are concerned, your identity verification will come in later. It does not happen at the transport layer. So it's just like going to a confession, now you want to make sure that you're confessing to the priest. As far as the priest is concerned, they don't want to know who you are. That's why design, but in this case, I mean, they would like to know who you are, but they cannot because of the limitations of the system. Now, of course, I mean, there is a mutually authenticated protocol in TLS, which is the new version of SSL after it was standardized by IETF, but that is not mandatory. So if you don't want to do it, you can still go ahead and start the session. Now, of course, at the application level, you may say, okay, if the mutual authentication is not done, I will not move forward. But at least from the protocol point of view, that's not mandatory. So now you would wonder, okay, well, from the user point of view, the user knows what server they're talking to. What about the server? How would the server know who you are? Now, the reason that this protocol was designed the way it was in the early days was because, as far as you are concerned, they wanted your credit card number back in the late 90s. I mean, the online commerce was picking up. You would say, okay, well, I want to purchase this thing or get this thing, and okay, well, what's your credit card number? Name, credit card number, done. And you could say, well, don't save it for me, because most often people did not trust what was happening on the internet. Now, at the same time, it was either cheaper or it was convenient, so they gave the credit card number, saying, okay, well, don't store it. And things worked fine. So mutually authenticated, yes. Done in the same protocol, no. At the transport layer, you would authenticate the server. In the application layer, you would authenticate the user. Now, in the current environment, we can still do the same thing. But now we are actually putting information on the server. So let's say if you go to Amazon, you don't want to enter your credit card number every time. So they have your credit card number, which means that now the burden of authenticating who you are is at the authentication layer. So it's not that even if you don't authenticate you well, you may not have the credit card number, so you're safe. No. The credit card number is there. If you get hold of somebody's account, now they log in and now they can impersonate you. So the burden of having a stronger authentication goes up higher. And now you would say, okay, well, how's the authentication done? So for better or worse, we all realize that passwords are still king. We've been trying to dismantle that castle for a long time. And if you look at this quote from Bill Gates, this is from RSA conference in 2004. So in San Francisco, he predicted, okay, passwords will be dead, because there's no doubt that over time, people are going to rely less and less on passwords. So in general, this statement is true. Over time, yes, people will rely less and less, but that stretch of time has been quite extensive. I mean, this was about 15 years ago, and we are still using password. And it was not just in this conference. Actually, the same claim was made a couple of months later in Copenhagen when he was addressing the Microsoft IT Forum. And the same thing there. Now, the difference over here was that now, instead of claiming that, okay, passwords will be dead, he gave an alternative. And that alternative was smart cards. Now, at that point, I mean, this was really good news for us, because we worked for Exalto at that time. Basically, the same company that now is Thales. I mean, over a bunch of Gemalto renaming and then being acquired by Thales. So we were actually working with Microsoft at that time to develop this this .NET card. And Karen, I don't know whether she's in the room, but Karen and I mean, one of my colleagues in Thales, we worked on the operating system layer and the security layer on this chip to create the mask, which was then used to do this. But the reality is that that thing didn't work. And the reason that it didn't work is not because of the technology, it was because of the usability. It's not that easy to carry a smart card. Now, are there other two-factor authentication solutions which are easy to carry? And the answer is, in most part, not really. And the reason for that is that people are still trying to find a solution, and passwords are still there. Last year in Ignite, so here's another claim from Microsoft, again claiming that the era of passwords is over. So it looks like that every year somebody claims that the era of passwords is over, but the passwords are still around. And the reason for that, of course, is because of this extra layer of burden that is put on the users to carry that device, and on the merchants or the service providers or the identity providers to basically issue those tokens. Now, having said that, I mean, there is some silver lining happening, because you can see that, well, Windows Hello is finding some alternative. We now have these authenticators. Microsoft has one, and Thales has one, Okta has one, Duo has one, and then similarly, another example would be FIDO. So with these things, I mean, things are changing, but the pace of that is not there. So let's look at dissect a little bit more about what these authentication methods are, and then we'll see how we can build the case for what really is needed. So when we talk about authentication, they come in various flavors. So I won't go into all of these details. I mean, suffice to say that, well, passwords is at the top, which is the most easiest one to implement. Then you could send an SMS as an OTP, not a real OTP in the sense of the algorithm, but a nonce, which the server can then verify. You send it to the phone, and then you relay it back on your access device, and now the server can say, aha, this is the same version of the code which I sent. Or you could have a more classical OTP where the algorithm is generated, and that could be done on software or in hardware. So depending on which one you pick, well, the security level could be higher, but the cost could be comparably different. Or you could do a PKI, where it's now based upon public-private keys, and you have that in your token, either in a smart card or in your phone. Or you could rely on some behavior and other stuff. Now, when you classify them, it's interesting to say, okay, well, these are all multi-factor authentications, and what we've been taught is that, okay, well, in order to be a multi-factor authenticator, you need to have a class of each. So for instance, I mean, you cannot have two passwords and claim that you're a multi-factor authenticator. So it needs to be what you know, which essentially is your PIN or password, what you have, which could be a smart card and other forms of token that I describe over here, or what you are, which is essentially some biometric trait about you, which is unique to you as a person. Now, over the years, what we've seen is that since those have been really difficult to implement and deploy, there have been what we call these supplementary forms of authenticators which have come on board. Now, you won't use these by themselves, but you can either pair them together, or more importantly, you'll basically combine them with one of the classical ones. And the most easiest to combine against is the password. So which means that, yes, I mean, you are doing additional forms of authentication using these supplementary forms, but the password is still around, because that's essentially hard to replace but easy to deploy. And the supplementary ones are, I mean, for instance, where you are, your geolocation, your network IP address, your surroundings. So for instance, I mean, if I say, well, I want to log in, and over Bluetooth connection, if my application on the web could figure out that, well, as long as I have my mobile phone with me, which I've already paired, let me log in. If I walk away with my phone in my hand, the application would close. So these are the things which are really interesting to implement, and people have been doing that. The problem with all of these is that it's still hard to deploy. And the reason that it's hard to deploy is because of this basic tight binding between what you have on the client side and what you have on the server side. So on the client side, you would have some application which does this authentication, and somehow it has to relay that information to the server, and the server has to validate that. Now, the way the server validates it is tied to the algorithm that you use on the client, which means that there's a tight binding. If I come up with a new algorithm, a new way of authenticating users, well, I have to go back and change the server as well. And that's always not so simple. And the contribution that FIDO standard has done is that it basically removes that barrier. It loosens up that tight binding between the client and the server, and essentially creates a common protocol pipe. So on the backend server, you could have a FIDO server which can now handle any kind of authenticator that you can put on the client. You could first do a deployment with only one kind of authenticator. The next day you go around, well, I want to support smart cards, so let's add that as the authenticator on the client side. And on the server side, you don't have to make any change at all. So that's an advantage that FIDO brings in order to address that. So on the authentication side, we've seen that, okay, well, passwords are there, but at the same time, we are making strides where we are doing things or moving things in the positive direction. The question is that enough? And as we've learned in the past, well, not really, because the problem now we get into is that, okay, well, you can authenticate nicely, but when you look at the enterprise landscape, there are three parties which are involved. There's the user, there's the enterprise, and then there's the service provider. And the service providers are the applications that you're using or other things that your enterprise wants you to be delegated to or forwarded to, so you can use those services. And if you're using the model that we have, all three have problems. From the user's point of view, there are too many credentials. So there's a credential that I use to log on to my company. There's another credential that I use to log on to service provider 1. And I'm sure that there are 3 or 4 more service providers that my enterprise wants me to log into, and I have to know the passwords for all of them. In case they move to a higher level of assurance and have a second factor, chances are that they'll all have their own second factor, which means they now have to carry 3 or 4 dongles with me. So the user is not happy at all. What about the company? Well, the company is not happy because now it doesn't have any control. The user could have elevated privileges by moving to a different role within the organization, and now they have to make sure that the set of services that they get from the service provider are tailored accordingly, and now they cannot do that. Or the user could leave the company, and since they still have access directly to the service provider, they could log in. So there's lack of control on the service provider side. I mean, on the enterprise side. What about the service provider? Equally unhappy, and probably more so. And the reason is that they do not want to deal with the authentication period. They want to focus on the service they are providing, and with dealing with authentication, they have to worry about users forgetting their passwords. Users have to change their passwords, so which means that they have to have all the deployment on their server side to allow the change, and in case that doesn't work, they need to have a support structure for on-call, so that users are not locked out. So with this scenario, everybody is unhappy. I mean, it kind of works, but everybody is unhappy. So the solution to that, of course, is the federation, where you have the identity provider in the middle. The user logs on to that IDP. The IDP has an association with the company, enterprise company, and the service providers. And by association, once you log on to the IDP, you're basically logged on to your enterprise as well as many service providers that they have. And here's where SAML and OpenID Connect come in. And using those bindings, you can log in. So the SSO is solved. And the companies that do that, I mean, Ping is one of them. They've made a lot of money by doing the single sign-on solution using their Ping Federate protocol. But then things are moving. And now people want to move beyond single sign-on. I was at the Cloud Identity Summit a couple of years ago where their CEO, Andre Durant, I mean, he was explaining, okay, well, this is where we are and this is where we are moving. And he didn't put anything on the y-axis, so we don't know whether it's revenue or whether it's the number of users or the number of customers. But the general trend you can see that their core base has been single sign-on, the federation protocol. Where they want to move to is access, which is essentially access management. And they're not the only ones. I mean, basically, all the other players, like Okta, Thales, Dio, Microsoft, they're all moving in the access management space. So authentication, yes, we need to have it, but it's not enough. Single sign-on, yes, we need to have it, but it's not enough either. So what's needed is access management. And in terms of access management, what we are saying is that, okay, well, it's not just that I logged in once at the perimeter. I need to be continuously monitored. Like, what do I have access to? Which applications are in, which applications are out? When can I have access? In the morning, in the afternoon, in the evening? From where can I have access? So there could be different rules when I'm in the office network. There could be different rules when I'm at home, and still different rules when I'm using a public internet service. And then how often do I authenticate? And when you combine all of these along with the other more factors, it very easily becomes very complex environment. Because now you're monitoring signals, you're making decisions about that signals, which means that it's not just, okay, well, I'm strong in authentication, in multi-factor authentication, I'm strong in single sign-on. Well, you have to combine a bunch of other technology components as well, like an identity governance and identity assurance, maybe, identity verification. So all of those things come into play. And the question is, how do we do that? And this is where several identity industry alliances would come in. So I'll talk about 3 of them, which I've been affiliated with in some capacity. And I picked them from different categories. So there's one which is the Internet Identity Workshop. So here's an example of a conference where like-minded people would go and they're all technologists and professionals, and they'll talk about identity. So that's IIW. The second one which I'll mention is IDSA, Identity Defined Security Alliance. So this is an alliance of like-minded companies in the identity space who come in and say, okay, well, what are the best practices that we should be promoting and telling people about? And the last one is Continuous Access Evaluation Protocol. So this is a standards body which is being formed to look at new standards, and there are architects who are coming in from different companies to define the standards for future. So let's do a quick check on what IIW is. So IIW, interestingly, when you look at it, I mean, I was surprised to see that they have a lot of similarity with the topic today, which is the meme that I'm quoting from Peter Steiner. So their logo is a dog that is looking at a laptop, and the dog has a human face mask on it. So lot of relation to that, and maybe they were inspired by his cartoon. Who knows? But the IIW. So this is a conference. By the way, has anybody attended one of these conferences? IIW. If not, and if you're interested in identity, I would strongly recommend go and attend one of them. I mean, they're every 6 months, so basically twice a year. Normally they isolate between East Coast and West Coast. The last one which I attended was in Mountain View a couple of weeks ago. And what they want to do is that they want to bring in people who work in the identity space. And the difference from what we see over here, let's say at LASCON, is that you come in, you have a set agenda, you have speakers who are already defined, and you know exactly who's giving what talk in what room. IIW, this is what they call the unconference. And what the unconference means is that there is no agenda whatsoever. You just show up, and the agenda is created dynamically. And the way it is created is that there's a meeting in the morning. So there were 300 of us, and you basically gather in a big circle, and people propose topics. And I'll show you a wall where people post their topics, and once they're done, then you essentially go to any topic that interests you. And they are slotted by an hour, so you could go to one section in 1 hour. If you don't like it, you move out, and then you go to another one, and people basically rotate. And the reason that they do that is because they say, well, innovation happens like you're standing and talking next to a coffee machine. And they want to do is that they want to replicate that informal environment. And there are 3 types of sessions that they have. There's the 101 session where they talk about certain technology. There's another session which could be like, okay, well, I have an idea, come listen. So I'm giving you a proposal, come listen, and then we can discuss. There can be another type of session which says, well, I have a problem, I don't know how to solve it. Please help me solve it. And they're all related to identity, authentication, access management, and you name it. And from this controlled chaos, in the end, somehow really interesting things happen. I mean, if you want, you can go to this this URL that I have, which has the session notes from this conference, and you'll see what kind of things they're talking about. Now, one thing which they are really proud of, and in fact they have that in their logo, which is endorsed by history, is that some of the interesting things that we use have come out of discussions that started at IIW. And foremost among them is the OpenID Connect standard. So OpenID Connect standard was picked up by OpenID Foundation, but its genesis was in IIW many years ago. So this is the example of the wall. I mean, after the opening session, people would basically post their slots over here, and you basically walk up to this wall and say, okay, well, what are they talking about? Let's say distributed identities. I want to attend that session, and you go there. So really an interesting mix. If you have not been there, highly recommend that you go and attend. The second one I would like to talk about, Identity Defined Security Alliance. So here's so this is an alliance of companies, and I'll show you the list over here. So there are about 25 or 30 companies which all are dealing with identity. As you can see, the names over here. Thales is part of that, by the way. And what we want to do is that we want to create 2 types of things. The first one is information about what recommendations we can give. So we can start with, let's say, what are the best practices for identity, how those best practices can be used to create what we call security controls, and then how those security controls can feed into what we call the use cases. So essentially, if you want to look at it as a pyramid, I mean, you could have a use case at the top which could be addressed by multiple security controls, which underneath would have multiple best practices. So you can essentially say that, okay, well, if I do this in my organization, let's say if I impose 2-factor authentication, what are the different use cases which I can solve? So we are trying to build this information where you can have building blocks which then get together to form real issues which are faced in the industry. And then instead of going into the detail of this, I mean, I'll just mention that this is one of the reference architectures that we have come up with, where you start off with the user on one end, and then you need to get to the data on the other hand. And what you have to go through is you go through a client application, or a client, not an application, because a client can have an application component, a compute component, a storage component. Then you go through the network layer, and then on the other side you have the server, the same things. And as you're going through each one of them, the question is that we want to maintain the user's identity to make sure that it is that user which is accessing a particular piece of the data. So this is the overall concept. And then essentially underneath you can see that these are the various technology components which come in. Now, one way that we have used this is in the publication of this white paper. So essentially we were looking at what things that the industry really wants to hear about, and we realized that, well, zero trust is something which is really quite common that people want to hear about. In fact, when I was at RSA earlier this year, I mean, you walk through the exhibition floor and all you hear are people touting that they have zero trust solution. I mean, and the question was, well, do people really understand what zero trust is? And when we step back a little, we realize that, well, there are two kinds of literature that you will find on zero trust. There's one which is coming from, let's say, Google, when they published their original Beyond Cope paper about almost 10 years ago now. And then you have other literature which says that, okay, I'm an enterprise, I use this paper and I implemented zero trust, and here's my case study. There's very little of other information out there. And what we wanted to do was that, given the expertise that we have in IDSA from all these 25 organizations, we want to have a collective output of what zero trust is for two things. One was that, okay, well, let's try to move the focus away from network centric representation of zero trust to something which is more identity centric. And secondly, of course, because the more minds you put together, the better output you get. So that's one work that we did. The second one is more an integration of how building blocks from one company can complement the building blocks of another. So I mentioned, okay, well, Ping is strong in single sign-on, but at the same time we have access management and multi-factor authentication solution which could be coming from Thales, and we could have PAM solution, let's say, the privileged access management solution which could be coming from, let's say, Beyond Trust. So on that, I mean, we have a talk which talks specifically about that. So if you're interested, I can point you to that talk. The next item is the continuous access evaluation protocol. And this is a new initiative which is still a bit nascent, but I think there's strong progress going on in this. So before I explain, I mean, who are the players who are working on this, let's find out why do we need CAPE, the continuous authentication. So if you look at this model, so this is what we have at the end of the federation. So you have the identity provider in the middle, the user, the company, and then the service provider. But the story doesn't stop here. I mean, the user could be connected to, let's say, 4 other or 5 other service providers. And what we want to find out in order to have a good implementation of zero trust is that if something goes wrong in one of these service providers, how would that information be reflected in my session with the first service provider? Now, the first service provider may not want to know what exactly I did wrong on SP5, but the fact that something went wrong on SP5 now puts into question the session that I have with the first service provider. And we are trying to do most of it right now, but it's hard to do in the absence of a standard. So for instance, if I want to implement everything on the service provider side itself, the service provider, the burden is on the service provider to make sure that it monitors all my activities. And that's hard to do. So with that in mind, the reason that the CAPE comes into picture is that, okay, well, we want to focus on zero trust. We want to make sure that the attack focus, as we know, that it's shifting from the network to the endpoint compromises. We also know that context matters, because it's not just that, okay, well, I've authenticated you at the perimeter. You want to do that continuously throughout the life cycle of that session, which means that the context sensitive information, as we talked about in access management earlier, they are important. And the question is, how do we implement them? And then at the same time, there are multiple sources. I mean, I could be logged in from my laptop, so the security posture of the laptop is in question. I could have used my phone as a second factor device, so the security posture of this phone is in question. I'm right now going over a VPN which is provided by the knowledge center, and I'm connected. So all of these things, I mean, you could have information which could be compromised at each of these layers. And the question is that, how do you address that? Which essentially points us to the fact that, well, right now there is no solution which will do that. So what CAPE does is that it creates this concept of publishers and subscribers. So essentially, a publisher will say, okay, here's a user that I know about, and this user is doing certain things, and I'll send out events whenever something bad happens. The subscriber would say, okay, well, I want to know about this user, and I'm subscribing to all the events that you're publishing. So the model is very simple. Of course, the details are, I mean, the devil is in the details on how the protocol is set up. But from the concept point of view, publisher, subscriber, express interest, and then based upon the signals that you get, have a policy engine which will decide what to do. So one example of that, the way we can put it in context, is that you start from here, from a device, and you're connecting to a relying party. So let's assume that authentication has been done. Now you're essentially engaging with the session back and forth with the service provider or the relying party. Normally what happens is you send in a request, and now a response comes back with either what you've asked for, or a rejection saying that, well, you can't have this for blah, 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 whatever reason. Now, in order to make this robust and continuous, the onus is on the relying party to manage all the signals. What CAPE offers is that it introduces this concept of publishers and subscribers. So now the relying party can say, well, first of all, I will tell somebody else, or I'll broadcast that this is what this user has done for this session. Again, I mean, the identity of the user and the privacy and exactly the details about what is done is still maintained, but you could articulate in a more abstract way that this is something which has happened, which is bad. On the policy server side, the policy server could be getting the same information from other subscribers or other publishers. And what comes back is a much more rich set of information to the relying party, which the relying party by itself could not have obtained. So these two back and forth remain as they are. What CAPE provides is this server-to-server communication between multiple nodes so that they can share the information about a particular user. Now, I said that this is fairly nascent and just starting to come into focus. And in fact, I mean, it has. I mean, right now the momentum is pretty strong. But where it started off was one blog that was posted by Atul Toshi from Google. And this got a lot of attention from a lot of companies. And so far, what we have had is that after this blog, there was one presentation done that was done earlier this year at Identiverse. And since then, we've had 2 face-to-face meetings, both hosted by Google. And it is now part of a standards body under OpenID Foundation. So just like OpenID Connect is under OpenID Foundation, and that's a standard. Similarly, the CAPE effort is now officially part of OpenID Foundation. In terms of the players, here are about 12 or 13 companies which are actively participating in this standard. Thales is again one of them. I'm representing the Thales team in this development of standards. But then, as you can see, I mean, the other ones, Google, Microsoft, Okta, Ping, Duo, I mean, all the major players in the identity space, they are there. What we feel is that it'll probably take another 1.5 to 2 years before it becomes a standard. And so far, all the input that we have received from the OpenID Foundation board, who know a thing or two about how standards work, is that there's a lot of need for this kind of a standardized way of communication and event exchange between parties to help with the authentication, the continuous authentication space. So the need seems to be there. The will seems to be there from these organizations. In fact, the two of the more promoters of this are Google and Microsoft. I mean, it's not that they are there just to put a face to the standard, but they are the ones who are one of the more actively involved participants. And in fact, that's why. So the first 2 face-to-face meetings were held in the Mountain View office of Google, rather Sunnyvale, I think. And then the next one, which is coming up in 3 weeks, will be in Seattle, hosted by Microsoft. So the standard is taking shape, but it's still about 1.5 to 2 years away. So if you're more interested in this, I mean, please get in touch with me. And we would like to have more participation in it, more companies that join in the identity space. I think it is good. But what everybody feels is that once the standard is done, then the next frontier would be the implementation. Because it could be a complex implementation in terms of how to manage the signals, how to make sure that the protocol is such that it doesn't become too chatty, that not that many messages flowing back and forth, because things happen at a very fast pace. And people feel that machine learning and AI would have a strong presence in this, because you want to create your competitive solutions. And the parties which are most interested in that, which I highlight a bit, I mean, not because they're most interested, but more because they have the muscle to carry this forward, because of the resources and the amount of money that they're spending in AI. So with that said, let's look at how AI would come into picture in not only CAPE but other flavors. So artificial intelligence and machine learning, I mean, this is again a buzzword. So again, at RSA and other conferences, zero trust was one buzzword, machine learning was the other. So people basically put that on their brochures even if they don't know what it means, which is fine, because I mean, this is something which is in vogue. And for a reason. I mean, people are doing really great things with this. But I just thought that, okay, well, before we talk about that, let's take a step back, and I would like to give you a little bit of a history. See, okay, well, where it all started. So this is Marvin Minsky. He passed away in 2016. One of the founders of AI. And really smart guy, got his education in Princeton and Harvard, got the Turing Award, which is given by the ACM annually. And he actually started the AI laboratory at MIT. And not only started that laboratory, but worked very closely with the Media Lab, the MIT Media Lab. And this is where a lot of groundbreaking research has been happening for the last many decades. And they are still on the forefront of what they do in AI. And if you want to learn more about that, I mean, there's a very nice book about the Media Lab, Inventing the Future, by Stuart Brand. I mean, this is a fairly old book, but I think they have a more recent version of that as well. This cover is from the older version. The reason that I brought this up was because in this book, I found a very interesting note from Minsky. So they talk about what they call the Minsky challenge. And what the Minsky challenge is that, okay, well, he posed this to his graduate students, saying, okay, well, you're building this massively parallel connection machine. See if you can write an algorithm where you can differentiate a cat from a dog. So this was the early days of AI, where we were talking about, well, what to do. And the reason that this is important is because what we feel sometimes is that money is following the research, that they would basically invest in research which is interesting in the hopes that it will basically render more interesting things. But in reality, sometimes you wonder that probably it's the other way around, especially when we see what's happening in the current time, where research is following where the money is. And it's trying to optimize already existing revenue streams. And we see that in how the companies are approaching AI currently and machine learning. So with that, I mean, since money and research, they are so closely tied together, I wanted to give you a little perspective of what are the most valuable companies today, and then how it has changed over time. So we can start from 1980, and IBM is the only technology company that you see there. The rest of them are telecom and oil. 2 oil companies, 1 oil services company. And 10 years later, IBM is still there. AT&T has gone because it's been broken up by the FCC into baby bells. But now we have pretty much the same mix. And then same thing continues in 2000. Cisco is now there because of the dot-com boom, as we talked about. The routers are in vogue and everybody wants one, so of course that boosts the stock of the company. But the rest of it is still there. I mean, we have General Electric, but it's not really a technology company. It's an appliance company, so you would not associate that. But then we have pharmaceutical, and then we have finance, and then oil is still there. In 2010, things tend to change a bit. I mean, Microsoft and Apple are coming up. The rest of the mix is still the same. I mean, General Electric is there. There's a financial company, Berkshire Hathaway, and then oil is still present. So this is every 10 years. But now 10 years has not even passed. I mean, it's from 2010, and we're not there at 220. And these numbers are from 2017. And already you can see that there's a clean sweep. All the top 5 companies are technology companies, what we refer to as GAFAM these days. Apple, Google, Microsoft, Facebook, and Amazon. And the question is, where are they spending their money? So we talked about the interconnect between research and money, and the money is all going into the race for AI. So this is just a snapshot of some of the acquisitions that they've done over the course of the years. And these are not small acquisitions. I mean, some either acquisitions or basically investing in startups. And some of these are really massive. So for instance, when you look at what Microsoft is doing with OpenAI, so that's a $1 billion investment. And the reason that they're doing that is because on the server side, they want to reap the benefits of manipulating machine learning and AI. And by the way, the reason that OpenAI is interesting is not because they are simulating things and they're doing things in software, but they're doing things in the physical world as well. So essentially, they can translate the complexities of a simulation into the physical world of the hand movement of a robot. So here's a robot that can actually solve a Rubik's Cube. So you basically drop the Rubik's Cube in its form and basically turn it on, and then before you know it, the cube will be solved. So here's the frontier of where we are heading. And it's not just the private sector which is doing that. I mean, we see the same thing happening by the Department of Defense. And generally, DoD has turned to the defense contractors to do the research for it. But in the case of AI, they are turning to the technology companies like Google and Amazon. Now, at the same time, people do point out that, well, of course, I mean, AI is still in the infancy to some extent, and there are glitches that happen. So this one was reported in MIT Technology Review, where they talked about the deep learning vision algorithm that DoD was using. It could be fooled into thinking that the turtle is a rifle. Now, for everybody else, I mean, the image to the left is a turtle, but when that algorithm looks at that, that comes back repeatedly with the assertion that that's a rifle. And what some people point out is that that's because of our deep reliance on what we call the deep learning. So just a little bit of a synopsis of what deep learning really means. So when you look at the artificial intelligence concept, I mean, so these are layers. So artificial context, AI is the top layer, where we say, okay, well, you do some things to the computer, to the software, and as long as the output is smart, you would call that AI. So that's a very broad area, and it has been around for years. I mean, when Marvin Minsky created the AI lab at MIT, that was decades ago. So the concept has been around, and some people think that that's old hat now, because the word has been around and there's very little to show for it. So they say, okay, well, let's think of something else. So from the marketer's point of view, machine learning is catchy in that respect, because it's a new phrase and people latch on to that. So that's why when you hear people say they talk about machine learning, they don't talk about AI, most of the literatures. And what machine learning does is it's the current implementation of AI, and the focus for them is, okay, give me a set of data, structured data, and then guide me on how to make sense of it, and then how to make predictions about the future. So that's essentially machine learning, learning from past information and then moving forward. Deep learning, on the other hand, is even more focused than that. It says, okay, Wes, give me data, and by the way, that data doesn't have to be structured, just like that turtle. And I'll figure it out what it is. And by the way, don't even hold my hand. I can do things on my own. And the reason that they're doing that in deep learning is because they want to mimic the neural networks of how humans behave. And that is always hard to do. Of course, I mean, eventually we'll get there, but right now, the algorithms that we have are a little off. And the question is, why does it matter? I mean, we started off with identity, with authentication, then we talked about CAPE, and we said, okay, well, in the CAPE framework, machine learning would be important, and we need that. But it's not just authentication and access management. I mean, the use of AI now and in future transcends everything. I mean, you can look at each of these things, from college admission all the way to the role in the criminal justice system. Everything would be driven and controlled by the algorithms which are created. And the question is that, well, how would that work? So for instance, I mean, if you take the example of the corporate promotion. So let's say you have an algorithm of picking somebody for promotion, and you want to pick that person for promotion based upon the prediction of how successful that person would be. If you're using data from the past, then you look at the data and you say, aha, well, what I see is that, well, in the past, historically, white males have been very dominant in the corporate world, and they have been successful. So now the algorithm is biased towards picking a white male for promotion. And that's what people have pointed out repeatedly in multiple studies, where the AI algorithms are biased. And people realize that they are, but the question is how to fix them. And that's where the notion of, well, do the deep learning, but at the same time, take it with a grain of salt. And one book which I recently found, I've not read this book yet, by the way, full disclaimer, but it looks interesting. I mean, the reviews are pretty good, by Gary Marcus. I mean, he's a professor at New York University and founder of a couple of AI startups that he created. And what he argues, as the title reflects, in adding trust to AI, because currently the software that is used to do AI, it does not have the trust of the users. And one reason for that could be because when we talk about trust, it's affiliated and associated with humans. I mean, you trust humans because you have rapport with them. The same trust does not transcend into machines and software as yet, because we've seen these glitches that the algorithms do. This is a very interesting clip about, if you search for data explains small talk. So data is basically trying to be human, and he says, okay, well, small talk is something that humans do quite casually. And he basically tries to do something and then says, well, I've written a subroutine to do that. And how did I do? And Picard says, well, it's a little too irrelevant. So if you really want to do, if you're really interested in small talk, then you should observe Commander Hutchinson. And Commander Hutchinson is the commander of the base that they are at. And I suspect that you go and observe him and how he does small talk, because he's a master. And Data says, I will. And that's machine learning for you, because now he'll. So if you look for the search for this clip, it'll be nice. as a closing thought. So thank you very much. You've been great audience, and thanks a lot.